Hello Dev, welcome back to the channel. In this video, we're going to explore the adapter design pattern. When do we use it? How is it implemented? Let's jump right in. Let's say you developed an application that uses XML data format, but in the future, you decide to change into a library that uses JSON data format. They probably have different interfaces to communicate with, meaning how does your code communicate with those libraries? So how can we consistently call any libraries in the same way as we were calling in the previous way? So if you guessed we have to adapt that new library, you guessed it right. We're going to make use of the adapter design pattern. What is the adapter design pattern? It is a structural design pattern that allows objects with different interfaces to collaborate with each other. By creating a middle class layer that acts as a translator or converter, or as the name of the pattern, an adapter, it allows for existing classes to work with newly created classes without changing their source code. You can think of it as plugging an adapter to your laptop charger when you're visiting a different country. The country outlet has one interface, your charger has one interface. They are not the same, so you must plug in an adapter between them so they can communicate. What are the elements of the adapter design pattern? Typically, we have an interface that defines the behaviors of our application. Then, we have a concrete class that implements that interface. It can be referred to as our original code in the adapter design pattern. Then, you find a new library, which is incompatible. So that's referred as the incompatible code, which is going to be adapted to. And finally, we have the adapter, which is the piece of code we create to seamlessly integrate the target, which was our interface, with the incompatible code and allow them to communicate. Let's take a look at the class diagram of the adapter design pattern. Here at the center, we have our target client interface, which is the one defining the behaviors of our application. We have also our original code that implements that interface. But then you decide to use the incompatible code, which is this one here at the right. You can see that the method signatures do not match. Incompatible code uses the method another method that takes an int, while our system uses the target interface, which defines the method with one argument string. So they are not compatible. How can we make them compatible? You create an adapter. This one is the one that acts as the converter or translator. So our adapter wraps the incompatible code as a reference here, and in our method, since it implements the interface, in this method, we provide the conversion steps necessary to make our code seamless integrate with the incompatible code. Now let's take a look at the code. Here in the IDE, we have an adapter pattern project. Let's take a look. First, we have a package, adapter structure, which is the structure of the adapter design pattern, which follows the UML class diagram we've seen before. If I expand and I'll go to the runner class, let's run this code first. As I run this code, you can see the output. It prints traditional method 1, another request type, also 1. Let's see how we invoked this code. So using the original code, we have a reference target named adaptee, instantiates the original code. Okay. Then from my adaptee, I invoke the method named method. It takes one string argument, which is the traditional or original request type. Then we create another instance also from target, which is named adapter reference, instantiate new adapter. From that reference, we invoke the same method with also one string parameter. Since both of them are from target, that's why we call the same method. So let's see under the hood. Let's take a look at our target interface first. So our target interface, defining the behaviors of our application, has only one method named method, and it takes one string parameter. Our original code implements that target, so it has to give a body to that method. And you can see traditional method and the string parameter we passed, which was 1 when we run it. And in the future, we found a new code, a new library. Here it is represented as a class that we defined in our package structure, but you can think of it as a newly created library that you imported. So if you go to incompatible code, you see that this does not follow the rules. It doesn't implement the interface target. Method signature is different. So the name is already different, another method. Argument list is also different. It takes an integer, not a string. To not change much my application, I would like to make the same method call. That's why we create the adapter class, which is the middle layer class. You can see that our adapter, it implements target. So meaning we have to follow the rules, we have to override the method and provide a body. Inside the adapter, we have a reference to the incompatible code. So we're repeating inside the adapter. Here is our constructor where we initialize our incompatible code. And since we have to implement the method that takes the original signature, which is method, with one string parameter, inside that method, we provide steps to convert into the incompatible code. So our original code invoked with a string, and in this method, we're converting a string into an integer, which then allows us to invoke the incompatible code, another method that has one int parameter. From the runner code, so who runs the code doesn't get affected. If I just swap them, this is my original code. Here we're showing it separately so we visualize. But if we just change the reference, for example, let's do this. This is seamless. It doesn't break my code. I'm using the adapter, not my original code, but my method calls are the same. For one method might not make that much sense, but imagine if you have a lot of methods or a chain of methods. Now let's take a look at another example. Here you have sample adapter and sample third party. Sample third party is to mimic a third party library. Let's take a look at the sample adapter. Sample adapter, here you can see the diagram. So here we have the client code that implements that interface. And we're going to replace the way that our application is handling it with the service code, which is our incompatible code. You can see that the method signatures do not match. That's why we create our adapter class. So if we go to run adapter, this is an application that displays menus. Only conceptually, we're not actually displaying menus. So when we run it, you can see that we display menus using XML data. Here you can see we have the call display menus and we pass an XML data variable. Then you have display recommendations with XML data, displaying recommendations with XML data in the output. Note that we're just using this XML data class to represent XML data. So if I go inside that class, you'll see that it is an empty class. Again, just to represent XML data. But now I'm going to use a new library, the latest library that actually uses JSON. So my new UI is going to be rendered using JSON and not XML anymore. So you can see the type here, iMulti-Resto App Client Interface is the same. This is the original. This is the adapted. Here we instantiate the fancy UI service. This was the original code. Let's see the original first. So in our class, in our original code, we implement the target interface, which overrides two methods. I'll briefly go there so we see. Overrides two methods, display menus and recommendations, both using XML as data type. As we go back to the original implementation, you give the bodies to the functions. This is just printing to represent the behavior. But now I want to use the third-party code that I found. So fancy UI service doesn't implement anything, but it does have two functions, two methods. One is show menus that takes JSON data. Other one show recommendations that takes JSON data as well. So how do we use this service in our method call display menus? Even the method name is different. The original, our target interface, display menus, and the fancy UI service. So instead of display, it's show. So back to our adapter. So we create the adapter class as the middle layer class. Implementing our target interface, we wrap that incompatible code inside it, instantiate it in our constructor. Since we implement the interface, we have to implement those methods. They take XML data. And inside those methods, I will provide the steps to convert one type to another, in this case, JSON to XML. And then I call the function of my incompatible code. So from fancy UI service, I will invoke show menus. So from the display menus method, I will invoke show menus. To who's calling the code, which in our case is this main method, they don't see anything. They just invoke display menus method. The instance is what is different. This is the fancy UI service adapter. And this is our original code multi-resto app client. So in our adapter, we convert one type to another, and then invoke the incompatible code. Similar to the second method. Convert XML to JSON, and you pass the XML, and then you use the incompatible code. Down here, we just have a simple representation method for converting XML to JSON. This is just printing text, and we could return a new JSON type here, for example. What are the key points of the adapter design pattern? It's useful when integrating new components with existing services, meaning integrating legacy code with new code. It also enables reuse of existing classes that don't have compatible interfaces. It also helps with single responsibility and open-closed principles. I hope you enjoyed this video. Hit the like button, let me know if you have any questions in the comment section down below. Subscribe to the channel for new videos, and I'll see you in the next one.